ground is moving significantly upward. We'd also combine that with seismic activity.
Yellowstone Caldera's magma reservoir contained substantial melt at depths that fueled prior eruptions.
Beneath the majestic landscape of Yellowstone National Park lies a ticking time bomb that scientists have been closely monitoring for decades. The looming threat of the supervolcano's eruption has long been the subject of scientific curiosity. But recent discoveries have left experts on edge. In a shocking revelation, scientists have detected a rare gas that has been locked away deep within the Earth's crust for billions of years. This gas, helium-4, is a key indicator of the supervolcano's impending eruption. But how does this volatile gas signal the eruption of one of the most destructive forces on the planet? Join us in today's video as we uncover the terrifying truth behind the helium-4 gas and the Yellowstone supervolcano. Nestled in the heart of Wyoming lies a seemingly tranquil national park that is home to a ticking time bomb, the Yellowstone caldera. This caldera is one of the world's most dangerous active supervolcanoes, capable of a catastrophic eruption with a magnitude of 8. It's a terrifying prospect, one that has scientists and experts on high alert at all times. Enter the Yellowstone Volcano Observatory, a group dedicated to monitoring the supervolcano's every move. Their job has never been more critical, as ominous signs of another eruption are looming on the horizon. Recently, the observatory made a shocking discovery, a rare gas that has not been seen for eons, ancient helium. This discovery is a clear indication that something big is brewing beneath the surface. Although helium is present in Yellowstone's hydrothermal features, the fact that it's spewing out of volcanic rocks is a troubling sign that cannot be ignored. According to the research conducted by scientists from the United States Geological Survey, Yellowstone National Park's gas emanates from deep within rocks where it has been sequestered for hundreds of millions of years. This astonishing discovery sheds new light on the rare occurrence of helium in the park, even though helium is the second most abundant element in the entire universe. On Earth, helium mainly occurs as helium-4, with 2 protons and 2 neutrons, which is produced through the decay of heavy elements such as uranium. Helium-3, on the other hand, is relatively rare, with 2 protons and 1 neutron, and has been present on Earth since the planet's formation. The proportion of helium-3 to helium-4 varies, and scientists can utilize that ratio to determine the source of any helium they come across. The high concentration of helium-3 in Yellowstone's hydrothermal system is a strong indication that the Yellowstone hotspot originates deep within the mantle and has a direct path to the surface. Scientists have found that the journey of helium-4 to the surface of Yellowstone is much more complicated than previously thought. For a decade, researchers from the United States Geological Survey collected gas samples from Yellowstone and its surrounding areas while analyzing the isotopic composition of helium, carbon dioxide, and other gases in those samples. Their findings revealed that the amount of helium-4 emanating from Yellowstone is significantly higher than what would be expected in other regions, and a significant portion of it is likely hundreds of millions or even billions of years old. Based on their calculations and analysis, the scientists concluded that this gas originates from rocks within an ancient crust buried in the area, which was formed over 2.5 billion years ago and contains uranium and other radioactive materials that have been decaying over time. It is believed that the Yellowstone hotspot cut through this ancient crust approximately 2 million years ago, releasing helium-4 stored in the rocks and helium-3 from the mantle. This latest discovery at Yellowstone might pique the interest of parkgoers, but for scientists, it's more than just intriguing, it's downright concerning. Helium and other noble gases are critical in assessing groundwater sources. The more helium-4 present in water, the longer the water has been sitting in its surrounding rocks. However, this new research on helium at Yellowstone suggests that some of these assumptions, particularly when it comes to helium-4 produced by the steady decay of elements found in local aquifers, aren't exactly accurate. Helium is notoriously unpredictable, and it can seep into a system unexpectedly from surprising sources like ancient rock pockets or magma sources. So, past calculations regarding dates, especially those related to aquifers near volcanic areas or earthquake faults, may be highly inaccurate due to the extra helium involved. Nevertheless, scientists are accustomed to adapting to new information that challenges long-held theories, as that's the essence of scientific discovery. Let's break it down. So you might be wondering, what exactly can helium tell us about volcanoes? The story began when one of Yellowstone's significant earthquakes hit, and it triggered a flurry of rumors and speculations. Some suggested that animals were fleeing the park in fear, and that the earthquake would cause a massive eruption, and that helium emissions were surging in the Yellowstone caldera, indicating an imminent eruption. However, these theories turned out to be false. The animals were just migrating, and the helium emissions were caused by other factors. Nevertheless, the discovery of helium emissions can potentially provide valuable insights into volcano monitoring in the future. It's important to note that helium can originate from two main sources, but each source has different variations. Primordial helium from the mantle is dominated by a lighter neutron, while helium produced from the decay of elements in the crust yields a heavier neutron known as an alpha particle. By analyzing the isotopic ratio of helium in soils, fumaroles, hot springs, or wells, scientists can determine the proportion of helium derived from magma degassing in the mantle or from the radioactive decay of uranium and thorium in the crust. If the helium-3 or helium-4 ratio is high, the mantle source is likely dominant, while a low ratio indicates a crustal source. Typically, these ratios are compared to the helium-3 and 4 ratios in the atmosphere, known as Ra, which is approximately 0.00001384. Thus, if the helium ratios are reported at multiple Ra, it indicates mantle sources, while for crustal sources, it's usually around 1 to 3 Ra. Picture this: a volcanic area that's about to blow its top. Now imagine two scientists carefully studying the situation. One of them, Padron, and a team of experts focused on the link between helium emissions from soil and water from a well on the Canary Islands. What they discovered was astounding. As earthquakes increased, so did helium emissions, from 9 to over 24 kilograms per day just before the eruption. But why? The scientists believed that the quakes created fractures for the helium to escape, like a natural fracking process, as magma bubbled up under the island. But that's not all. The closer the magma got to the surface, the more helium was released, causing a surge in emissions. After the eruption, the amount of helium decreased with decreasing seismic activity. But when earthquakes picked up again, the helium emissions followed suit. Interestingly, the ratio of helium-3 and helium-4 didn't increase. Instead, it suggested that the helium was coming from the island's crust, not from magma. Although new earthquakes created cracks for the helium to escape, it wasn't entirely related to new magma. Even more surprising, helium emissions peaked at 38 kilograms per day, well after the initial eruption. Overall, the helium emissions closely tracked seismic activity, while helium-3 and helium-4 tracked with the rising of magma into the crust until the eruption. Recent studies have been keeping a close eye on the helium levels in volcanic regions, and it turns out they've found some pretty intriguing results. In California's Mammoth Mountain, the helium-3 and helium-4 levels rose with seismic activity, indicating that moving magma in the crust is causing earthquake swarms. However, when it comes to Yellowstone, things get a little more complicated. In a nature study, Lowenstein and his colleagues discovered that the areas with the highest levels of helium emissions, such as the Heart Lake Geyser Basin, are actually releasing mostly crust-derived helium, rather than any magma bubbling beneath Yellowstone. Now let's break down this scientific puzzle about Yellowstone and its helium emissions. The helium-3 and helium-4 ratios in the caldera, the heart of the volcano, are as high as 10 to 17 Ra, but close to the mantle hotspot compositions of almost 220 Ra. But at Hartley, the base of the helium-3 and 4 is less than 2.5 Ra, indicating that crustal sources are the dominant factor. So what's going on? Lowenstein and his team did some calculations and found that the amount of helium-4 being released in the Yellowstone area is nearly 600 times more than what should be produced by the decay of uranium and thorium. This suggests that the helium-4 is from trapped helium that's been hanging around for millions, maybe even billions of years. But here's where things get tricky. The amount of helium being released doesn't necessarily indicate that magma is on the move. Earthquakes can liberate helium, just like any other gas. To determine whether changes in helium emissions are related to magma, we need to understand the helium ratio. Unfortunately, we can't measure helium ratios quickly and easily in the field. Samples need to be taken back to a lab for analysis. So if we only consider the amount of helium being released, we're only getting part of the story. There's much more to learn about this complex supervolcano. Imagine you're standing on your street, watching floodwater rushing past you. But is it just a result of the heavy rain, or is there a burst water main up the road causing the chaos? Just measuring the amount of water isn't going to give you the answers you need. In the same way, measuring the amount of helium being released by a volcano isn't enough to tell us what's happening beneath the surface. However, recent studies of helium emissions at El Hierro and Yellowstone are teaching us a lot about the processes happening inside volcanoes. We now know that the consumption of helium can be disconnected from the emissions, and that there can be significant amounts of stored helium in the crust that can be released by processes unrelated to an eruption. We're making progress in our ability to anticipate volcanic activity, but we need to be careful not to get ahead of ourselves without fully understanding the situation. Furthermore, Yellowstone has been causing some concern among its residents as scientists have discovered more information about the amount of liquid magma present under the supervolcano. The higher the amount of liquid magma, the more likely it is for the volcano to erupt. While previous research had estimated that the shallower reservoir was mostly solid, recent analysis using powerful supercomputers has revealed that it's actually 16 to 20% melted rock. However, this amount is still below the threshold of liquid magma that would trigger an eruption, which scientists believe is about 35 to 50%. Nevertheless, this new information represents a significant improvement in our understanding of what lies beneath Yellowstone. With the added discovery of helium emissions, some may wonder if an eruption is imminent. What do you think? Share your thoughts in the comments below.